In this part of the tutorial, I'm going to be covering structs. Structs are sort of like territories, just like scopes and libraries are, but they have a whole lot more to them. Just like the others, they have a pretty common code block structure, struct, and then you have a name here like name. And for our purposes, we are always going to be writing extends array. There are struct features that are written in by vjass when you don't write this, but we're not going to use those features for now until we fully understand them. So let's leave them out and just have a plain old empty struct. And an empty struct literally has no code to it. Whatever we write is the only code that's going to be in there. Now structs are sort of like really advanced arrays as well. If I wrote something in here like integer I, notice first I didn't need a globals block. So you can just freely declare globals inside of structs and you won't need globals blocks. And second, this integer is actually an array. And within the struct is accessed using the this keyword, which is just an integer, it's nothing special. And if you want to see it, I'm going to put syntax here really fast and save. Oh, maybe that was a bad spot for a syntax error. Oh. So let's go ahead and look again. Really? There we go. And let's go up to the globals block and look for the I. That's probably a bad variable name since it's short. And there it is, integer array I. Now you may be thinking it's kind of strange to make this into an array, but the reason for this is because structs are instantiated. This means you can have multiple instances of a struct. You could create and destroy structs just like you create and destroy units or anything else. And so this array, each index in the array represents a value for an instance in the struct. So index 0 of the array would represent instance 0 of the struct, which is not possible to get because instance 0 is regarded as null. If you create an allocator and actually use instance 0, people will be very upset at you because everybody uses instance 0 as null. Yes, it wastes one index space, but nobody cares. I don't care either. It's null, so there. Huh. So then, how do you create a plain old variable that's not an array inside of a struct? We have to use what's called the static keyword. So if we put the static in front of it, now it's a plain old array. This translates just into integer I. Without the static, it translates into integer array I. So the static keyword allows us to do something like that since it's just a plain old variable now. You may also notice that structs are a lot nicer to work in because they don't require the globals block either. And for initializing code, you don't need an initializer either, so that's really nice. Instead, you do private static method on init takes nothing, turns nothing, and method. And if you'll look here, that's colorized. It's because it's a special struct method. And it's initializer, so it's private. Notice the static keyword there. The new things are methods here. Inside of structs, you use method instead of function. Method and function are the same thing. You just have to do it that way because that's what Vexorian decided. And he created vjass, and so he gets what he wants. So this code down here, the on init, will automatically run, which is pretty cool. And we can do like call print I2SI and display the 5. And there is the 5 right there. So that's pretty nice. Easier, less code. I always work with structs myself. Plus the API, which is the interface of your system, how people use your system, like the function calls and so on. The APIs when using structs are much nicer. Do you remember the nonsense with scopes? Like if you want to have a public function in a scope, it would be scope function name or something. Well, with structs, it's struct dot function name. So the dot just looks nicer, I guess. And so if we wanted to access this I here, let's change this around. How about first struct? It will be first struct.I. And then like normal, you can have private variables. They can only be accessed within the struct. And probably want to name that I too. What about regular methods? So this onInit essentially turns into private function. onInit takes nothing, returns nothing, and function. And it's automatically called by the vjass, whatever. It automatically calls this without us having to worry about it. Anyways, private methods or regular methods don't translate into plain old functions. If we had something like method test takes nothing, returns nothing, and method, that would actually translate into function test takes integer this, returns nothing, and function. And notice how this is once again just an integer. Why it does this is because it's essentially taking the instance. So remember, structs are instantiated. You can create them and destroy them just like units and whatnot. So you can have instantiated methods as well that take a struct instance. And then if you had something like integer p, you could do set p equal 5, and that translates into set p this equal 5. So the this keyword is automatically used for array variables. If you had something like stack integer array p2 though, you can just do set p2 equal 5. Because then that is treated like an actual array within the struct. So for that you'd have to actually do set p2 this equal 5 or set p2 9 equal 5 or whatever. So structs really aren't that difficult. Now when you create a struct, it's like creating a new type in your language, like a whole new variable type, like an integer or a unit. And we can use that struct just like a type. So if I go down to actions down here, I can type first struct, there's the type, and then I. And there's the variable right there. So instead of an integer or a unit, I have first struct, which is just the struct name, and then I can save it. And it looks like I had a typo or something there. I5? Okay, it is not liking that for some reason. Okay, let's try it up here. Function test. Maybe first instead? First H. First testing. Oh, I know why. Ha, ha. I'm too used to C++ at the moment. C++ does not require the local keyword there, so I was typing it without. Now it works. So we can go back to first struct and then local first struct I. Okay, so just like I said, variable type and then variable name. And in this case, the variable type is in fact a struct. And what's great about this is if we have a method up here, method boo takes nothing, returns nothing, and method, and we set this I to something like 5, we can do something like call I.boo. And this essentially translates into call boo I. So that's pretty nice syntax right there. It's like if you wanted to do set unit.health equal 5 instead of set health unit equal 5, or call unit.move instead of call move unit. It's just a bit different, but to me it looks nicer. And then that I is passed in as the this keyword, so we can do call print I2s this, and it should print 5. Let's change that into 13, so now this should print 13. Let's get rid of this for now. So there is the 13. Now over here I arbitrarily set this variable to some number, but what you'd normally use is first struct.create. I don't have create up here right now, but you'd create the struct first, then you'd use it for a while, and then eventually when you're done with it you destroy it. And I would have like a static method create takes nothing, returns first struct, so I'm returning the struct type. Then I'd have return end method. For now I'm going to say return 0. Then over here I'd have method destroy takes nothing, returns nothing, end method, and destroy. And in here what is done is allocation, initialization, and then return. In here it is clean up and then deallocation. So you might have something like creating a unit. So first you want to allocate, create unit, then return the allocated instance. Then over here you'd want to destroy the unit and deallocate the passed in instance. And the reason create and destroy are removed is just because that's the standard. You could use whatever you'd want. You could even use allocate, deallocate, or generate and ungenerate, whatever you like. But people will be upset if it's not create and destroy, because that is the standard. And notice here that when it's a static method, when it's static, you can just use the struct name, or you can use a variable of that type. So I could do like call I.create, and that would just be like call create, since it's static. So yeah, structs are a little bit confusing, but they're really nice to work with. And then later when we work with allocation and whatnot, they're going to be even nicer to work with. There's one other thing I'm going to cover with structs for now, and that is the this type keyword. It's a special type of keyword, and when you use it inside the struct, it just turns into the struct name. So if I said this type I, or I should have a local there, so local this type I, that would translate into local first struct I. So it just makes it, if you change the struct name at one point, you won't have to go through all your code and change it everywhere. And when you see a create method, you're always going to see it return this type, just because that's easier to work with. And then there's actually one other thing I am going to cover with structs, and that is typecasting. Typecasting is essentially converting something like an integer to a struct. Because if you remember, structs instances are literally just integers, so there's no reason why you can't convert between them. And to do this, you can use the struct keyword, for example, first struct, parentheses, and then what you want to convert. So for example, I'll convert 15. And then you can do .boo or whatever. So this converts, and I should have a call there. This converts 15 into first struct and then calls boo with it. and so that would be callBoo 15. It seems harder to do it that way. You could also use this type if you're inside of the struct. But, well, it seems harder to do it that way. It's okay, I guess. A lot of the time you'll use this type 0 for allocators and deallocators, because 0 is the special null thing, so that's what you use for your allocators and deallocators. And anyways, that's about all you need to know for structs for now. There are other things like method operators, but we'll cover those at a later date. For now, you know regular methods, static methods, and how to do variables and structs, and how to declare struct variables and use struct variables, and that's about it. Now, if you get rid of this extends array, you will in fact be able to do create and destroy. As you just found out. You can do that for now if you want to have instantiation, but I do not recommend it, because vjass adds in quite a bit of extra code, especially when you have a thing called polymorphism. And the overhead on things called polymorphism in JAS is incredibly massive. In Galaxy, you can actually do polymorphism now with the latest patch, 1.5, and it works beautifully. And there's no problem with it or anything. But in JAS, polymorphism is like death itself. So don't use it in JAS. If you want polymorphism, move on to StarCraft 2, or go to another language that actually supports it, like C++ and C# and whatnot. So just don't use them in JAS. Anyways, that concludes this tutorial on structs. The next tutorial will cover the rest of the stuff you need to know for structs.